Agave Utahensis is a relatively young species of a relatively young genus, that is, agave. And I actually think it's one of the most fascinating agaves there are. And agaves, I think, are one of the most fascinating kind of plants, particularly because of their relationship with humans throughout history. Agave Utahensis can actually be used to help us understand the geological history, the climate history, and the human history of the desert Southwest, and in particular, the area around Las Vegas. So today we're going to be talking about the history of Agave Utahensis. Genetic research published in a paper in 2006 found that agave as a genus is a relatively young one, probably only 7.1 to 10.1 million years old. Another paper published in 2006 found that the aridification of North America, of the desert Southwest, that took place about 15 million years ago, was critical to the evolution of the genus. And both studies identified Mexico as the geographic center, the origin point for the genus agave, which from there spread into northern South America, Central America, and into the southwest of what we now call the United States. The desertification that drove that evolution took place during a period of global warming called the Miocene epoch. A mountain alongside a coastline can produce what's known as a rain shadow desert on the non-coastline side of the range. As moisture-rich air is blown over the tops of these peaks, cooler temperatures at the higher elevations force the moisture out of the clouds into precipitation, and it rains on the coastal side of the mountain range. But on the non-coastal side of the mountain range, what's known as a rain shadow desert is created. This is exactly what happened when the Sierra Nevada, Cascade, and Andes Mountains all were formed during the Miocene epoch. The Miocene period was then followed by the Pleistocene, essentially the last ice age, which started about 2.5 million years ago and ended around 11,000 years ago. It is during the end of this period that most archaeologists believe that humans started to migrate to North America. In the 1950s, archaeologist Richard McNash found evidence of human use of agave in the Tehuacan Valley in central Mexico that dated back probably as far as about 10,000 years ago. In 2011, rope made from agave was actually found in caves in the Andes in northern Peru that dated back to something like 12,000 years ago. And groups such as the Hohokam in what is now Arizona actually cultivated and domesticated agave in around 600 CE. In an article in the Cactus and Succulent Society Journal in 2020, Matt Maggio, Agave Utahensis researcher, said that the Spring Mountains here just outside of Las Vegas were the heart of Agave Utahensis territory. But what is it about these mountains that make it the perfect habitat for Agave Utahensis? Before the breakup of Earth's last supercontinent, Pangaea, about 250 million years ago, southern Nevada was the site of an ancient sea. Millions of years of ocean debris died and fell to the floor of that sea and created the limestone that now makes up much of the Spring Mountain range. And that limestone is critical because Utahensis is a calciphile plant, that is, it prefers to live on calcium-rich soils like limestone. As Pangaea broke up, tectonic forces shoved that fossil-rich limestone up into the air and actually created what we now know as the Spring Mountains. During that Miocene desertification we discussed was important for the development of agave about 10 to 15 million years ago, the Sierra Nevada mountains, which formed just to the west of Nevada, actually created one of those rain shadow deserts here in southern Nevada. 7 million years later, during the Pleistocene, that last great ice age, southern Nevada was actually considerably cooler than it is today. So species like Agave Utahensis, which while being a desert species is actually fairly sensitive to extreme high temperatures, being the northernmost and most cold hardy form of agave, could have lived across the valley in places that are much too hot for it in today's climate. But at the end of the Pleistocene, 11,000 years ago, temperatures warmed and southern Nevada became the hot desert climate that it is today, and Agave Utahensis was restricted only to growing in specific bands of elevation on the mountaintop, effectively forming what's known as sky islands. Right? Individual populations are isolated up into those mountains, and there is really no contact with other populations because essentially they're separated by a sea of desert. In his seminal book on agaves of North America, Howard Scott Gentry, legendary agave botanist, says that Agave Utahensis has variable inflorescence. It can have one of 3 different kinds of flower structure. spigot inflorescences, racemose inflorescences, and paniculate inflorescences. And experts typically agree that this variable inflorescence indicates that Agave utahensis is the result of recent field hybridization. That is, on a relatively, in evolutionary terms, recent point in history, two different kinds of agave met in the field, cross-pollinated, and created the hybrid that we now know today as Agave utahensis. One of the taxa of Agave utahensis, subspecies cababensis, in fact, does not have a variable inflorescence. Cababensis only grows paniculate inflorescences. So many experts take that to mean that it is not the product of a recent field hybridization, and it in fact might be the oldest form of Agave utahensis in evolutionary terms, or maybe even potentially one of the two parent species that created the hybrid that we know as the other forms of Agave utahensis. It's difficult and probably impossible to actually know 100% certainty which two agave species were the parents that created the hybrid that is now utahensis. Cababensis, as I mentioned, is a likely good candidate for one of them, but as far as the other one is, we don't really know. Good guesses would be agave species like McKelviana or Agave perii, which probably shared habitat during the Pleistocene. And it's difficult to determine exactly when, probably impossible to determine exactly when that hybridization occurred. My guesstimate, based on this research, my reading of the research, probably during the late Pleistocene when temperatures were such that Agave utahensis and other agave species that live in this area would have had a much wider range and many more opportunities to interact and cross-pollinate. Carbon dating of rodent droppings around the Grand Canyon have found that Agave utahensis existed there around 20,000 years ago. It's likely that it existed there much older, but as far as I could find in the research, that's the oldest confirmation of Agave utahensis specifically. But what's important about that 20,000 years ago estimate is that it shows that Agave utahensis was present during the Pleistocene, during the last ice age, when it could have had a much wider habitat than it does today. And agave probably became a very important food source after the end of the Pleistocene when temperatures were warming and made big game hunting much more difficult. Famous botanist George Engelmann was the first European researcher to formally describe Agave utahensis in 1871. And he did so based on a sample collected in 1870 in St. George, Utah. Variety nevadensis was first formally described in 1929 by two other botanists referring to private notes from Engelmann. He was referring to a sample collected in 1882 in Ivanpah, California. And then variety Borespina was formally identified, actually in the Cactus and Succulent Society journals, or what's now the Journal of the Cactus and Succulent Society, in 1943, based on a sample collected at Peekaboo Range just north of Las Vegas. And finally, 7 years later in 1949, Agave utahensis, subspecies cababensis, was the final taxa to be formally described, based on a sample collected on the Kaibab Plateau in Arizona around the Grand Canyon. Earlier botanists had actually photographed and sampled this particular variety, or this particular subspecies, but just thought it was a colossal or really big form of utahensis. Now today, Agave utahensis is an internet sensation. It's many ornamental agave collectors and desert plant and cactus type of plant collectors' favorite agave, and it's found a huge market both domestically here in the United States and in North America, as well as overseas in Asia and in Europe. So I'd love to know what you think down in the comments. Do you think that Agave utahensis was the result of a relatively recent field hybridization? And if so, what's your best guess as to what its two parents might be?